Welcome to our notes on conic sections and ellipses. Students will be able to create the standard form equation of an ellipse, identifying properties such as the center, foci, vertices, or major axis and minor axis after reading a guided text. An ellipse is a set of all points in the plane whose distances from two fixed points in the plane, the foci of the ellipse, have a constant sum. So the foci, there's two of them for an ellipse, and they will be found here. The line through the foci and the vertices is called the focal axis. So for example, the line that describes the green line I just drew is going to be the focal axis for that ellipse, and this green line is going to be the focal axis for that ellipse. The line segment connecting the two vertices is called the major axis. So what I actually highlighted in green goes from vertex to vertex. That's the major axis. The length of the semi-major axis, which is A, is the distance from the center to the vertices. The major axis length is 2 times A. The line segment through the center perpendicular to the focal axis is called the minor axis of the ellipse. So that would be here and here on these ellipses. It connects the two co-vertices. The length of the semi-minor axis B is the distance from the center to the co-vertices, and the minor axis length is 2 times B. The center of the ellipse is midway between the foci. The center is also midway between the vertices and also midway between the co-vertices. Now we have a Pythagorean relationship in which c squared equals a squared minus b squared. C in the Pythagorean relation represents the length from the center to the foci. Here's a beneficial table that kind of summarizes a lot of this information. The standard equation changes depending on whether or not you have an ellipse that stretches horizontally or an ellipse that stretches vertically. If it stretches horizontally, then x minus h squared will be over a squared. But if it stretches vertically, then y minus k squared will be over a squared. A is always going to be bigger than b. I should say that right now. So a should always be bigger than b. If not, something is wrong, and you should check your work. So we're going to mark up this graph and find the following properties. If you have a graph of an ellipse, the easiest thing to do is to find the vertices. So here's my first vertex. I know it's my vertex and not my co-vertex because it stretches horizontally. So my major axis is going to be horizontal. So my first vertex is going to be -8, -1, and my second one is going to be 2, -1. Now my co-vertices, here's my co-vertex, 1, they're going to be on the minor axis. So my co-vertices are -3, 3, and -3, -5. All right, so it's actually quite easy to figure out where the center is in this case. It's going to have the same y value as your vertices, and it's going to have the same x value as your co-vertices here. So there's my center. My center is going to be at -3, -1. And now to find the semi-major axis length, that is going to be this distance right here. So I'm going to count. That's 1, 2, 3, 4, 5. So A equals 5. Now for the minor axis length, that's going to be this distance. And I'm going to count that. 1, 2, 3, 4. So B equals 4. Now, in order to figure out where my foci are, I have to first figure out what the c value is in my Pythagorean relationship. So c squared equals a squared minus b squared. Well, a is 5, so 5 squared is 25, and b is 4. B squared is 16, so 25 minus 16 equals 9. If c squared equals 9, then that means c equals 3. From there, what I can do is I can count 3 units to the left of the center. So 1, 2, 3. I'll be right here. That's going to be my first focus point. And I'm going to count 3 units to the right of the center. So 1, 2, 3. And that is my second focus. So the first one is at -6, -1, and the other is at 0, -1. So now it's asking for the focal axis. Our focal axis is horizontal, and it's actually y equals -1. And now for the standard equation. So because my focal axis is horizontal, it's being stretched horizontally. So like I like to think that it's longer on the x. So I'm going to write my x's first. X minus h, which in this case is minus -3, so plus 3 squared. I'm going to put this over the a value since it's the biggest. So 5 squared is 25 plus y minus k, so y minus -1 or y plus 1 squared over 16 equals 1. And that is the equation of our ellipse. So now, why don't you try the second example?